going to present my entire screen to you. So you should be, so all we're going to do is an example right now of something that is a very similar problem to task 3's problem, okay? Task 3 talked about grades, and you had to do a big spreadsheet on grades, and you had to use the spreadsheet to create your normal curve, okay? There are plenty of instructions and videos that you can pause and watch 5 million times on, okay? And from what I saw coming in, most of us did a really good job with the instructions. There's a few of you that had your data skewed in a really weird way. Just make sure that, I think you had too much data at the end, and if you take some of that off, and I think it's the bins, yeah, that might solve that situation, okay? All right, so here's a normal curve. Good old standard normal curve. I'm gonna keep my mouth shut for like a whole 30 seconds. Sketch that normal curve really fast. On whatever piece of paper, whiteboard, whatever you want, sketch that really fast. Okay, so I pulled some data. It's not good data. I was trying to come up with a lot of numbers really, really fast. And it didn't end up being normally distributed, but we're going to play with it like it is, okay? You're not even going to see the data. You're just going to see the pieces that I have here. So we are given temperatures over, say, the last 160 hours, okay? And they're normally distributed with a mean of 79.4 and a standard deviation, I should say I was typing fast, it's 10.5 degrees. Create a normal curve and answer the following questions. So the first thing I'm going to do is when I see normally distributed and I see normal curve, I know I'm drawing that picture that's right here on the screen, okay? So we've got our picture, and I'm going to go to my little draw menu. And the first thing I'm going to do is whatever my value is that is in the middle, or the mean, I'm going to write that right here in the middle. So I'm going to write 79.4. And I purposely used ugly values, okay? Then what I need to do is, in order to go this direction, I need to add the standard deviation. So I'm going to add that 10.5, which was it 10.5? Is that what I said? 10.5, which is the standard deviation, okay? All right, so when I've already done the calculations, I went and did them. So when I start, I'm gonna tell you what I got. And if I got a number wrong, let me know, okay? I got 89.9. I got 100.4. And I got 110.9 going that way. All right, I'm gonna go this way now. Okay, to go that way, I'm going to subtract 10.5 for the standard deviation. Okay, so when I go that way, I would get 68.9, 58.4, and 48.4. And then if my percentages are not written in there, I'm going to write my percentages in. Okay. Now, I tried to do the best I could to set up a problem that was similar, but not exactly the same. So I'm going to tell you, hey, you've got some categories. You've got to label your standard deviations in. When you put this in the context of the performance task, these are the grades. So this would have been like the F, the D, the C, the B, and the A. Okay, so that's what they're kind of equivalent to. I was trying to come up with categories. They are not good categories, but they'll work for what our purposes are. Okay, so this is saying that I'm supposed to label less than standard 2 deviations cooler. That means right in here, I am labeling as cooler. Okay. Go ahead, Matt. Thank you. I had a boo-boo in my calculation, didn't I? It looks like I subtracted 10, doesn't it? 47 point, what did you say? 40, thank you for catching my mistake. maybe I made it on purpose to see if someone was paying attention. We're going to go with that. Other than I just messed up. Okay. All right. So we know that we're in between here. It is cooler. Okay. And I appreciate, Matthew, you interrupted me in catching that. All right. And then the next set between 2 and 1 is warm. So in here, any temperature that lands in there, we're going to call warm. Even though I don't think between 58 and 68 is warm, we're going to go with it. Okay. And here's the part that's a little trickier. In between here and here, everything in there we're going to consider hot. Meaning if this was the performance task, everything in there is a C. Everything in between, and only what's in between there. Okay. Some of you on the task had an issue and you went back and went to traditional scale. You got like a 68 on the fake test, right? And you said, hey, I got a D, but no, you didn't. You got something else, okay? You have to go back to whatever the numbers are on your normal curve, okay? All right, and then my next one is hotter. So in this section here, I am hotter, okay? And then in this section down here, I am beastly hot. That's as creative as I could come up with this morning, okay? So we're labeling that as if you were labeling the labels on your A, B, C, D, F, okay, when you're doing your performance task. Okay, so let's look at what question 1 says. Now this is the middle questions on the task. Okay, so these are not the first questions on the task. This is kind of the middle set of questions on the task before you attach all of your work. Okay, and it says use your normal curve. So I'm going to go back and I'm going to use my normal curve to calculate all of this stuff. Okay, what percentages of temperatures are hot or greater? And this is where a lot of people fell into trouble. Okay, hot or greater, I'm going to highlight something. Don't highlight this. Does not start there. So it doesn't start there. You can highlight this. It starts here and goes up. Okay, so it doesn't start at your mean and go up. It starts at the edge of that window and goes up. So it said hot or greater. And when I do this, I'm adding these percentages together. Okay, so I'm going to go ahead and add those up. So this one would be 34 plus 34 plus 13.5 plus 2.5, and that equals 84%. All right, and you got to watch your word. It said percentage, so I'm leaving it in percentage. The next one says probability, so I have to do something slightly different. This time it says the temperature is less than 58.4. Okay, so I'm going to go scroll back up. I'm going to look for 58.4, and it magically is there because I purposely set this up so it was on there. Okay, so here's 58.4. I got to go less than. All I have to work with are the percentages, so I'm going to start with the percentages and add them up. So I would add up the 0.15 plus the 2.35, so I know that I have 2.5%. But that's percent. We want probability. To get probability, we shift our decimal place twice. So my probability is 0.025. All right. Question 3, how many total hours were hot? I meant to type hotter, not hot. Were hotter or beastly hot. I'll give you a second if you want to write any of that down. So how many total hours were hotter or beastly hot? Okay, so I'm going to go back to my normal curve. Okay, so I'm going to find everything that says hotter, so 13.5%, and then beastly hot covered both of those percentages, and I'm going to add the percentages up. So I would get 13.5 plus I didn't do the number right. This calculation. Oh no, I didn't. 13.5 plus 2.35 plus 0.15. I believe that comes out to be 16. Am I right? Catch my mistake. That's 16%. I'm going to add it again just to make sure. 13.5 plus 2.35 plus 0.15. Okay, yep, 16%. But that's not what the question was asking me. It didn't ask me about percentage. It didn't even ask me about probability. It asked me how many total hours were hotter or beastly hot. So I have to look for my total hours. I was told that this was only 160 hours of data. So I know that 16% of the 160 hours of data are hotter or beastly hot. So I'm going to do decimal point. So 0.16 times the 160. I'm going to do that really quick because I times, not add. Times 0.16 times 160. I really miss having you guys in class and making you do this on your calculators. All right, so 25.6 of the hours were hotter or beastly hot. Hours hotter or beastly hot. Okay. Normally I make you do way more work. All right, so hopefully that helps with that middle section. What we're going to do next is the top section, because that middle section, the normal curve only allows us to do so much. It only allows us to we're confined to these values, right? When I do the normal curve. But if I use a z-score, I can get a lot more values. Okay, so we're going to use the z-score for this next part. And some of you did fabulous with this, and some of you needed just a little bit of extra help. Okay, so first of all, I'm going to say, hey, the category, and this would be the test score you spun on the task, right, is 85.2. Okay, so I'm going to look at what category temperature do I end up in. So I do have to go back to my normal curve. I was at 85.2. 85.2 would be in here somewhere, right? 85.2, so it looks like I am in the hot category. And again, that's where some of you messed up. You want to make sure that you aren't going by the traditional scale. You are going by the scale that you calculated in the normal curve, okay? All right, now we have to figure out how many hours are below my temperature and how many hours are above my temperature, and that's when the z-score comes in. So I've got to calculate my z-score. So to get your z-score, you take whatever value you were randomly given, right, that you spun on the wheel. And then you're going to subtract the mean and divide by the standard deviation. So my mean, they told us in the original problem, was 79.4 and standard deviation 10.5. So 79.4 and 10.5. All right, when you calculate your z-score, I got 0.55. Some of you were stopping there and using that as your percentage that you multiplied by. You can't stop there, okay? That's the z-score. That is not the probability. We need to use the table. So you're going to use the table to find probability. Okay, so there's a z-score table. It's attached to the website that was for this task. Okay, I'm going to go find my z-score table. I had it up. Oh, or not. I lost it. Let me get it out of Google Drive yet again. I had it going. I swear I did. Let's see if it pops up. Nope. My drive. Trig. Statistics. Yours, it is linked to that website, so you can find it. And where is my... There it is. Ah! What happened? It all went backwards the other way. I lost it totally. Ah! Tables. There it is, z-score. Okay. All right, so I'm using this table. Okay. I am going to find so it was 0.55. So notice this part of the table, it's all negatives, right? This part of the table here is all positives. So I'm going to use 0.5, and then I'm going to go all the way out to 5 because that's the second decimal place. It gives us a little bit more accuracy than the one we did in the homework. So my probability is 0.7088. So I'm going to use that number. Okay, so the probability is 0.7088. That means that the probability that it is less than my temperature, or in your case, my score. Okay, so what I'm going to do with that number is I'm going to take that probability and I'm going to multiply it by the total number of temperatures. Okay, so when I did that, I got 113.408. It doesn't make sense in this context to have part of an hour, so I'm going to say 113 approximately. So if those are the number of hours that are below my temperature, to get the number of hours that are above my temperature, I would do 160 and subtract the 113, which would get me that 47 temperatures are below that. I need to actually see you do these calculations. So I gave that comment back on a lot of people's things, is that I couldn't see your calculations, so I didn't know how you were getting your numbers. Because I had to grade, 50, the 50 that actually turned them in, I graded, and I need to be actually to see how did you do your calculation, okay? So make sure that that's the written work that gets submitted, is that you show me your calculations, okay, on paper. Or some of you have done the whiteboards, that's fine. I'm liking seeing the whiteboards on homework. If you figured out how to use Cami and you have a device that you can write on with a stylus, use Cami. I'm okay with that. You can take your notes on that if you want. If you've got a device that does that, you're fortunate enough to have that. That's perfect, okay? I would prefer we all do that personally, but our devices can't all handle that yet, okay? All right, let me talk. I'm going to stop the recording part, and I'm going to talk a little bit about what the rest of this week and the expectation for this week is.